Hello and welcome to Morehouse's Math Menagerie. Today we're going to talk about one sample significance tests for a proportion. Before we begin, I thought we could look at this motivational poster that describes a lot of my teaching. Here's the problem we're looking at today. The AP scores for each state are released by the College Board every year. According to this report, in 2016, 51.86% of the 1,100 students who took the AP statistics exam in Idaho earned a passing score. In the same year, Mr. Morehouse had 68 students take the AP statistics exam, and 42 of them earned a passing score. Mr. Morehouse wants to know if this is convincing evidence that the proportion of his students who earn a passing score on the AP statistics exam is higher than the state proportion. We're going to use an alpha of 0.05. Step one is to set up the parameter and hypotheses. For the parameter, we're going to say let P equal the proportion of Mr. Morehouse's students who earn a passing score on the AP statistics exam. For the null hypothesis, we're going to say that P equals 0.5186. That would be the state proportion. For the alternative, we're going to say let P be greater than 0.5186, since Mr. Morehouse wants to know if his proportion is greater than the state's proportion. We don't need to relist the alpha level here since it was stated in the problem, but I thought I would do so anyways. Alpha is, again, 0.05. Step two is the conditions. There are three conditions here. The first one is that we have a random sample. Now, this was not a simple random sample since Mr. Morehouse's class is a convenient sample, but we're going to kind of pretend for this problem. Normally, in the problem itself, it'll say that we took a random sample, but we're going to gloss over this one for today. The 10% condition is met since 10 times 68 is 680, which is less than the population of 1,100. And last, the sampling distribution is approximately normal since the large counts condition is met. And we've checked both n times p and n times 1 minus p. I do want to point out here that we're using p and not p hat for this condition, since it's assumed that the proportion from the state is the true proportion for the population. Step three is the calculations. I'll show you how to do them by hand and then how to do them using the calculator. Our p hat is 0.6178. We got that by dividing 42 by the 68 students Mr. Morehouse had in class. Our z test statistic is going to be calculated by taking our data value p hat, subtracting p, the given proportion in the problem, and then dividing by the standard deviation of the sampling distribution. If we plug all those values in, we end up with a test statistic of 1.6339. Now, to find our p-value, we want to look at the area to the right of that z-value. Since our alternative hypothesis is a greater than, we want to know the proportion of values in the distribution that are greater than our test statistic of 1.6339. We can use normal CDF to find this, and we end up with a p-value of 0.0511. Now, if we wanted to use a calculator, we could use the 1prop_z_test function under stat tests. We would put in the p naught, which is the proportion from our null hypothesis, 0.5186. We would then put in our sample data, 42 successes who passed the exam, over a sample size of 68. We would then select the alternative as p is greater than the given value. Remember, our null hypothesis was that p is greater than 0.5186. If we hit calculate, we're given some information here. We're given the z test statistic, our p, which is the p value. Be careful here, this p is the p value, our sample proportion p hat, and then our sample size of 68. Remember, if you're showing work when using the calculator, you need to write out 1prop_z_test list the z-value and the p-value, and then also list out the sample size and the p-hat as well. This is considered showing your work. Here's a picture of some rainbow bagels I made a few years ago. They sure do look nice, but they didn't taste very good. Now, the last step in our 4-step process for a significance test is the conclusion. We're going to say that the p-value of 0.0511 is greater than our alpha of 0.05. Thus, we fail to reject the null hypothesis in favor of the alternative hypothesis. There is insufficient evidence to suggest that the proportion P of Mr. Morehouse's students who earn a passing grade on the AP statistics exam is higher than the state proportion. Thank you for joining us, and have a great day.